and welcome back to my channel. In this video we are going to discuss the last 3 questions of October-November 2019 9709111 series, and that is the question number 9, 10th and 11th. So let's start with question number 9th. So here is the question number 9. A curve for which dy over dx is given as 5x minus 1 to the power 1 by 2 minus 2 passes through the point 2, 3 and find the equation of curve. So whenever differentiation is given and we need to find the equation of curve, it is directly, if it is dy over dx, so y will be integration of the function which is given here, and that is 5x minus 1 to the power 1 by 2 and minus 2 and then dx of it. So we'll integrate it. We can see it is like 5x minus 1 to the power 1 by 2, so we'll take 5x integration of this, it is 5x minus 1 to the power 1 by 2 plus 1, and the resultant of 1 by 2 plus 1 you will divide, and that is going to be 2 by 3 here, and plus and minus, it is 2 constant, so minus 2 times x plus constant of integration, which I'll take it as c. So I got a equation of the equation of curve as y is equal to this minus 2x. Now we will find the value of this constant of integration by putting this value of x and y, because since it is lying on the, it is passing, this curve is passing through this point, it means it will satisfy this curve, equation of the curve. So we will put this 2 and 3 at the place of x and y respectively, and we will get it as 3 is equal to 2 over 3 times, it is 5 into 2 10 minus 1 9 raised to the power 1 by 2 is going to be 3, and 3 cube, that is going to be 27 into 1 upon 5 minus 2 into 2 and plus c. So we can see it is minus 4 here, other side it would be plus 4, so it is 7. So we can write from here that c is equal to 7, and the things, this is going to be subtracted over other side, and it is 9 2s are 18 over 5. So the answer, final answer is 17 over 5. So this is the constant of integration. That's why the final, that is the equation of curve, would be y is equal to 2 over 15 times 5x minus 1 to the power 3 by 2 minus 2x plus 17 over 5. So that's the equation of curve, and let's do the next part of it. Second part is we need to find double derivative of it. So since we have dy over dx, it is given as, so we'll differentiate it again. So the left hand side would become d2y over dx square, and right hand side is the chain rule. First of all, 1 upon 2 times 5x minus 1 to the power 1 by 2 minus 1, and multiply by the differentiation of this over dx square as 5 over 2, and since it is going to be minus 1 by 2, so I'll take it in the denominator, and I will get 5x minus 1 to the power 1 by 2. Since in the numerator it is minus 1 by 2, in the denominator it would be minus plus 1 by 2. So we could have leave it here also, that's completely fine. So the third part is find the coordinates of the stationary point on the curve, first thing, and then showing all your necessary working, determine the nature of this stationary point. So for the stationary point, first of all, dy over dx should be equal to 0, and we have dy over dx as this. So if we'll make this is equal to 0, so we will get 5x minus 1 raised to the power 1 by 2 is equal to 2. I have transferred this minus to the other side, and taking the square of both the side, we will get 5x minus 1 is equal to 4, which will give x is equal to, that is 5 upon 5 1. So x is equal to 1. So now we got x is equal to 1, so we can calculate the value of y, because we require the coordinates of the stationary point. And from the first part we know it is going to be y was 2 over 15 times 5x minus 1 to the power 3 by 2 minus 2x plus 17 over 5. So from here, if we put x is equal to 1, we can see it is 5 minus 1 4, 4 root is 2, cube is 8, so 8 to the 16 by 15. So from here we got 16 over 15 minus 2 plus 17 over 5, and that is 7 over 15. So we got the point coordinates of the stationary point, and that is 1 comma 37 over 15. I'll write like this. I could have written in the form of a decimal also, but that's fine. This is the stationary point, that is coordinates of the stationary point. Now since we have d2y over dx square as well, and this is 5 by 2 times 5x minus 1 to the power 1 by 2, it is in the denominator. So when we'll put x is equal to 1 in this, we will get it as 5 over 2 and 5 minus 1, 5 into 1 1 minus 5 into 1 5 minus 1 4 root is 2, so it is going to be 2, that is 5 over 4, which is greater than 0, hence it is going to be, hence stationary point is minimum. So this was the question of 4 marks. First of all, we need to find the stationary point, and then its nature of the stationary point's nature, that is whether it is a minimum or maximum. So let's do the next question. Here's the question number 10. Related to an origin O, the position vectors of points A, B, C and D, like for just instance, if we take this as origin, then OA vector, OB vector, OC vector and OD vector are like AB, if they have provided A, B, C and D position vector, that is OA, OB, OC and OD, like it is given. We need to show that AB is perpendicular to BC, so we require to find this vector AB, and then we can find the vector BC, and we'll do their dot products. If the dot product is 0, it means the vectors are perpendicular to each other. So let's find what is AB. So AB vector will be OB vector minus OA vector, so I'll do it directly here. OB minus OA, 2 minus minus 1, it is 3, minus 3 minus 3 is minus 6, and 5 minus minus 4. And similarly we can find what is the BC vector, and BC vector is position vector of C minus position vector of B. It is like we need to know if their position vectors are given, then AB vector is always going to be OB vector minus OC vector, that is position vector of B minus position vector of A, position vector of A. In the same way, if it is BC vector, then we will find the difference of subtract the OB vector from OC vector. So 4 minus 2, it is 2, minus 2 minus minus 3, it is going to be plus 3, so plus 3 minus 2 is 1, and 5 minus 5 is 0. So we got both the vectors. We will find their dot products. So AB dot BC is going to be is perpendicular to BC, or we can say BC is perpendicular to AB, both are same thing. So let's do the next part of it. So here's the second part. Show that ABCD is a trapezium. So I'll bring the diagram here first of all. Yeah, so here's the diagram. We need to show that this is a trapezium. So all we need to show here that if these two are parallel, then we can say directly that it is a trapezium. So we already have AB. AB is AB vector from the previous part. It is 3 minus 6 9, Now we need to find DC vector. So DC vector from the, since we have again position vector of C and position vector of D, so DC vector is position vector of C minus position vector of D, that is 4 minus 2 2 and minus 2 and minus 2 minus 2, so it is minus 4, and 5 minus minus 1, so it is 6. So we have DC vector. Now if we somehow prove or find a constant such that AB is lambda times or k times DC, then we can say that these two vectors are parallel. So here we can see, we can rewrite it as, I can take 3 common from the first AB vector, we will get 1 minus 2 and 3 here. The same thing, if I take 2 common from here, I will get 1 minus 2 and 3. So we can see that they are product of a same vector. So I can directly say that AB vector, I will rewrite it, AB and 3, so that it does not change the value of AB vector. I have multiplied and divided by 2. Now I can see this thing, this vector is DC vector, so we can write it as 3 by 2 times DC vector. So now since AB is a scalar product of DC, so AB and DC are parallel, so it's not required to apply the vector, it is okay. AB is a line, DC is a line, they are parallel, and hence ABCD is a trapezium. So I hope it is okay. Let's do the next part of it. Here's the third part of this question. Find the area of ABCD giving your answer correct to 2 decimal place. So in the second part we have proved that this is a trapezium, so we will use the formula of trapezium to find this area, that is half of sum of the parallel sides into the height, distance between the parallel sides. So let me bring the diagram here once more. So here is the diagram. We have AB vector, we have DC vector, we have BC vector as well. So all we need to find their magnitude, that is the length of the vector. So I'll write AB again. AB vector was 3 minus 6 and 9, 3 minus 6 and 9. So from here we can get magnitude of AB vector, and that is going to be square root of 3 square, that is 9, plus 6 square, minus 6 and 6 both are squares are going to be same, that is 36, and plus 9 square is 81, so it becomes square root of 126. And then BC vector also we have. BC vector was 210. So from here the magnitude of BC vector would be square root of 2 square, that is 4, plus 1 square 1, and plus 0 square, so no need to write, it is square root of 5. And the last is DC vector, which we have got in the previous part also. DC vector was 2 minus 4 and 6. So from here the magnitude of DC vector will calculate, and that is going to be square root of 2, that is 4, square root of square of 2 plus square of 4 plus square of 6, that is 36, and it become 56. So square root of 56. So required area is going to be 1 upon 2 times sum of parallel side, that is AB plus DC magnitude, AB plus DC. So it become square root of 126 plus square root of 56 into the height between them, that is BC magnitude, so it is root 5. And now we will calculate this from the calculator, and this is going to be 20.92. It is from the calculator, so this 20.92 square unit. So whatever is the unit of this length, that is going to be square unit. So this is the area of this trapezium. I hope it is clear. Let's do the next question. Here's the question number 11. That is the last question of this exam, this paper. The question is, the diagram shows a shaded region bounded by the y-axis, line y is equal to -1, and the part of the curve y is equal to x square plus 4x plus 3. Now we and this is for x greater than or equal to -2. The first part is, express this in the form of y is equal to x plus a whole square plus b, where a and b are constants. Hence, for x greater than or equal to -2, express x in terms of y. So first part is by the completing square method, and for completing square method we only require these two terms, and if x square coefficient is 1, so it is simply what is the coefficient of x, that is 4, so it would be x plus 2 whole square, and that is half of 4, that is 2, and subtract the square of 2, that is 4, and plus 3 was already here, so it become x plus 2 whole square minus 1. So that is in the form of x plus a whole square plus b. Now the next part is, we need to express x in terms of y. So from here we can write x plus 2 whole square as y plus 1, and that's why x plus 2 will be plus minus square root of y plus 1, or x is equal to -2 plus minus square root of y plus 1. Now we have to decide from this condition that whether we are going to choose plus or minus. So since it is given that x is always greater than or equal to -2, so we cannot subtract anything from -2, so it should be plus. So from here we can write x is equal to -2 plus square root of y plus 1. So we'll not take negative sign here, it is only plus. I hope it is clear. Let's do the next question. So this is the last part of the question 11, that is the second part and the last question also. So the question is, hence showing all your necessary working, find the volume obtained when the shaded region is rotated through 360 about y-axis. So it is if rotated about y-axis, so we are going to find the volume. There are two formulas, so we need to be very careful when it is rotated about y-axis and when it is rotated about x-axis. So if it is rotated about y-axis, it is going to be pi times x square and dy, not y square dx. So let me bring the diagram here. So we can see we are going to rotate about it and we'll get a volume here if you'll rotate. So the volume, the limit of y, we can see from -1 to this point. So the limit would be from -1 to 3, and from the first part we have got x is equal to -2 and plus square root of y plus 1, and we have this curve also. So from here, from this curve, x square is equal to y minus 4x minus 3. So if we remove this x also with the help of this, we will get x square is equal to y minus 4 times -2 plus square root of y plus 1 minus 3. So I'll simplify a little bit further. It is going to be y minus plus 8 minus 4 root y plus 1 and minus 3. So here again like term, 8 minus 3, it is 5. So it is finally y minus 4 root y plus 1 and plus 5. So the volume, required volume from here we'll get by integrating it, pi from -1 to 3 y minus 4. I'll write this root as the power y plus 1 to the power 1 by 2. plus 5 and then dy, because we know the integration formula for this x to the power n type, so it is there now. Now we'll do the integration and I'll put the limits afterward. So I'll put a square bracket here, and y integration is y square upon 2, and this 4 minus 4 as it is, and y plus 1 to the power 1 by 2, it would be y plus 1 to the power 1 by 2 plus 1, that is 3 by 2, and then divide by 3 by 2 will make it as 4 2 is 8 over 3, and plus 5 integration is 5y, and the limits from minus 1 to 3. So let's put the limits now. Then volume will be pi times, when you put y upper limit as 3, then it would be 9 by 2 minus, if it is 3 plus 1 4, root is 2, cube is 8, so 8 8s are 64 by 3, plus 5 3s are 15, and minus the whole thing with the limit minus 1. So it is going to be minus 1 square by 2, that is 1 by 2, and minus 1 plus 1 is 0, so it is 0, and minus 5. So now it become, I'll simplify the bracket, it is going to be 9 by 2, that is 4.5, minus 64 over 3, and plus it is 15 and it is minus 5, so it would become plus 5, and 15 plus 5 is 20, minus 1 by 2. So we'll put this in the calculator and we'll get the answer. So it become 8 by 3 pi, or in the decimal it is going to be 8.377 and all. So until 3 significant figure we write the answer, so it is 8.38 unit cube. So that's it. I hope you must have got everything from this paper. So see you in the next video with another past year paper solution. Thank you so much.